Greetings, sir. I am Matson's HNP, student number 612-65039, and I'm going to be presenting the project for Water Infrastructure and Resource Management, which is WRM 3701. I will be taking you through the slides that I've created for this project. So this is a TPC Local Municipality Water Services Development Plan, and my table of content looks like this. And we have the introduction, background, locality map, general layout, methodology, IPANET findings, calculations, and conclusions. So I have been appointed as an engineering technologist to make an analysis of water supply projects to be implemented by the TPC local municipality. The project is intended to provide water supply to the four townships in line with its Water Services Development Plan, WSDP. In this project, I am tasked with designing the water supply distribution network using IPANET software for the four townships of TPC local municipality. As an engineering technologist, the municipality expects me to carry out the following. Number pump stations are required, storage capacity of the bulk reservoir, head loss for each component, hydraulic profiles for pumping mains and pipe sizes, hydraulic profiles for the gravity mains, evaluate of need for pressure and surge control. So here we have the locality map of how the townships are aligned. And this is the general layout, which is inclusive of the reduced levels for each demand centers and the length of each pipes. I'm going to be taking you through the methodology. So IPANET software will be used to analyze and size the water supply components, and literature reviewed will guide decisions regarding the water supply projects. The water demand for the four township is given in the table below. So we are given the average daily demand of water in each township as follows. I then downloaded the IPANET software and started using it and following the general layout that was given to us. And this is how I laid out my network to look like, showing all the demand sensors and the bulk storage reservoir, the Shikalo water treatment plant, the abstraction works, and the Nyango River as the source. So once I uploaded all the elevations and named all my pipes and ensured that all the pipe sizes were the correct sizes that will ensure that the run is successful of my software, of my network distribution. So this is the pump curve volume. So we're given 650, 620 as the volume with 620 as the flow and 85 as the head. So this was the graph that was produced by IPANET, and we went on to do the average daily demand versus time graph, and this is what was produced there. And at first, when I ran the IPANET file, it was not successful because I used 300 millimeter pipe, which were given as the primary pipe diameters. I then adjusted my pipe sizes and increasing them gradually, also ensuring that the velocity does not exceed 1.5 meters per second. And then I was able to finally have a successful run of IPANET, which means that everything was going according to plan. And then I also did the network table, and in here you'll see that we have the elevations, which were added, elevations for each junction and the tank and the reservoir. And we have our base demand as given in the in the practical brief. And here we have our initial quality, we have our demand LPS and head, and it shows positive pressures, which means everything is going accordingly. And then we also have the hydraulic profiles of pressure at 0 hours, and this is what ARPANET produced. We also did the system flow graph velocity for selected links. So I just selected a few links here just to show the velocity, how it varies from link to link. And I also did the unit head loss for selected links, and of course we had to ensure that the head loss is 10%. And then went ahead and did the calculations. So since we're given that the abstraction works is will be considered as our as zero elevation, so it will be considered as our ground level for this whole distribution network. So we then subtracted the reduced levels for all other coordinates from the 8984 of the abstraction mix, and we get the elevation for each component as follows. And then I did calculations. So the total average daily demand, if you add all the average daily demand given, you get 355 liters per second. And the bulk reservoir tank should provide 8 hours of water supply without any pump at night. So uh, this is the water storage required. So according to the average daily demand for all four township, we're supposed to have a storage tank of 10 to 224 meters cubed. So the proposed storage required in this project was 10 to 44 meter cubed and allow for 12.5 meter height times 34.5 meter diameter. So the tank size was 11,685.252 meter cubed. So this is the volume of the tank, which is efficient to supply the average daily demand for all four townships, which would have been supplied by 102,024 meter cubed. So therefore, all the townships will be guaranteed to get enough water and there will be no shortages. So, in conclusion, ARPANET software is recommended to be used as a tool to analyze hydraulic designs to ensure that before you begin any project related to this, you have something concrete to guide you to a successful water supply design network. This could be an efficient method that can save cost because you'll know exactly how to go about constructing the project plans and you'll have a guide as to how to structure your network in a way that will yield positive results. At first, the Ibanez run had failed and I had to adjust the pipe diameters. There, I've learned a great deal about how the pressure and velocities within the flow can be affected negatively due to the size of the pipe selected. And I have better understanding about hydraulics thanks to this project. In this project, I was able to create a distribution network which ensured that all four townships will have access to clean water and there will be no shortages. Thank you.